Welcome to Troubleshooting Tools and Techniques, the first lesson of Step 14, Maintain and Troubleshoot. In this video, I'll talk about how you can use a troubleshooting methodology as a systematic approach for problem solving. In later videos, you'll see this apply to resolving such topics as installation and client communication issues. Then we'll spend some time covering troubleshooting tools and how you can use them to resolve semantic endpoint protection issues in your environment. Finally, you'll learn which SEPM and SEP logs to research when troubleshooting issues, such as database-related issues or content updates. And if you do need to do research on a particular issue, I'll show you how to interact with semantic support. Let's get started. When troubleshooting a problem, you gather evidence, research, repair, and validate. Gather evidence means that you're establishing what the symptoms are. You may find out what the user's opinion is, start gathering logs, and reproduce the issue. Researching means exactly that. You've documented the symptoms, you have an error message, and you're engaging resources like the semantic knowledge base. If it's an issue that's network or database related, you may decide to phone a peer to see if the resource is available. You might also decide to turn on debug logging to gather more information. The repair and validate phase is where you apply a corrective action. A corrective action is reactive. It's designed to remove the cause of an unacceptable situation. Depending on the type of issue, you may decide to apply a preventative action as well. A preventative action is proactive and designed to ensure the problem doesn't happen in the future. This slide shows a systematic approach to the troubleshooting cycle, meaning that you may have to gather evidence, research, repair, and validate multiple times. A good example of this would be if you have a server experiencing multiple issues. You may have to go through the troubleshooting cycle multiple times before the server can be put back online. The first step is to gather evidence and summarize the issues. During this phase, you gather keywords that make up the symptoms and document the steps to reproduce. Logs give you the ability to establish a timeline of what led up to the issue, and screenshots can help capture error messages. If you have access to a live system, even better. But at the end, you can reduce multiple issues to a single unified issue. It's a good idea to also summarize the issue using several keywords. That way you have a problem statement for the research phase. You can also create a short list of potential causes to help identify what caused the issue. Next, analyze the evidence. State the root cause and create an action plan to implement the fix. Analyzing evidence means that you're building a timeline from the logs showing what happened before and after the failure. You can gather error codes and, depending on what you find, reproduce with debug enabled. Based on the information that you find, you can create a query for searching in the semantic knowledge base. Other resources are Semantic Connect and also support, which I'll talk about how to engage later in the video. At the end of the research phase, you'll have a root cause to target and an action plan that you can use to implement a fix. Finally, repair, validate, take notes, and determine how to handle feedback. This is the lessons learned phase, how to improve the SEP environment. It's always a good rule of thumb to test fixes on a test machine first. A test machine could be a VM or an endpoint located in a group where the owner is more receptive to change. It's a good idea to test multiple times to ensure the issue doesn't return, and then implement the fix in your production environment. At the end, you'll want to take notes and document for further reference. You can also send feedback to support and other semantic parties, such as Semantic Connect. Now that we've covered the troubleshooting methodology, let's talk about some of the tools that you'll use when resolving SEP issues. SymDiag is a diagnostic tool used with many semantic products. If you're going through the labs in this course, you'll learn how to run SimDiag to find solutions to different types of problems. In your own environment, run SimDiag before troubleshooting on your own. You can identify common issues, gather data for support, verify licensing information, and discover potential malware. Download SimDiag from the SEP client or the SEPM. If the SEP client or SEPM are not available, go to the following knowledge base document and download the tool. In addition to using SimDiag, the labs in this course also require the use of third-party tools to help maintain and troubleshoot Solucel's semantic endpoint protection environment. With Wireshark, it's important that you gather current data and take note of the timestamp when the issue occurs. Having a timeline of events significantly expedites the logs analysis. The link shown on the screen is a tutorial on how to use Wireshark to troubleshoot SEP issues. You can download the Wireshark tool from wireshark.org and also search the web for videos on how to use Wireshark. Both Telnet and Netstat are command line tools built into Windows. Telnet is helpful for determining whether ports are open, listening, and available for action. For example, when you're troubleshooting a communication issue with the SEPM and clients are appearing as offline, you can use Telnet from one of the offline clients to connect to the SEPM over the communication port. If the connection does not work, it's an indicator that the port is blocked or not listening. At that point, you can check to make sure that the SEPM is online and accepting client requests. If you're at a machine that is having issues with receiving communication requests, Netstat is helpful for displaying network connections. In the example of an offline SEPM, you could run Netstat to make sure that the SEPM is listening for new connections. If you want to look for a particular type of connection, such as only active TCP connections, you can add parameters to Netstat to filter the output that it displays. Sysinternals is a suite of free Windows admin tools to perform almost any administrative task. If you're troubleshooting a semantic endpoint protection issue, but you're unable to be in front of the machine, you can use PSExec to run SimDiag remotely. Process Monitor captures log events for autoprotect, real-time scans, or permission-related issues. For example, if you're experiencing slowness during a scheduled scan, you can see the files being scanned in Process Monitor while the scan is running. Process Explorer is another sysinternals utility that is popular for its malware detection capabilities. It shows both parent and child relationships, including orphan processes. Orphan processes are suspect as threats because sometimes they impersonate Windows processes such as Explorer.exe. You can look at the process version, description, and icons. Most malware does not have version and icons. Also, take a look at the process path to make sure that it maps to a legitimate location. If it's running from an unusual or suspicious location, it's a good indicator that the process may be a potential threat. For more information on how you can use sysinternals with semantic endpoint protection, see the KB and Connect articles shown on the screen. But with troubleshooting comes logs, so let's take a look at the SEPM and SEP logs that you'll be interacting with in later lessons. Logs provide a timeline of what led up to the issue. You review logs during the gather evidence phase. When reviewing semantic endpoint protection logs, you'll see 3 different log extensions. Anything with a log extension is considered generic logging. For example, the semantic endpoint protection install log uses a .log extension. In this log, you'll see events ranging from information to critical. If the extension ends with a .out, then it shows output for a given process or service. For example, Catalina.out, which is used by Apache Tomcat in the Semantic Endpoint Protection Manager. If the process or service experiences issues, you may see files with a .error extension. A good example would be Catalina.error also used by the Symantec Endpoint Protection Manager. The following diagram shows key logs used when troubleshooting issues on the SEPM. Note the db_connection-x.log is named db_connection-0.log, and the SCM server-x.log is actually SCM-server-0.log. So when the file size reaches 10 megabytes, a second file will be created, and you'll notice a db_connection-1.log or SCM server-1.log and so on. Basically, these settings are the default configuration, and you can actually customize them in the conf.properties under the Tomcat etc folder. So the benefit is that you have the ability to have multiple logs so that if you want to look further back, you have multiple sets of logs in your Tomcat logs directory. Kind of cool. You can also locate most SEPM installation errors in the sepm_inst.log. Just search for the value 3 and then review the line above the return value. You'll see an explanation of the error, and also you can look in the Windows Event Viewer for more installation errors. In the viewer, you can just search for and warning messages. And for more information on installation and migration issues, you can see the KB article shown on the screen. And we'll talk more about this in the installation lesson. This screen describes 3 important database logs. You're going to interact with db_connect and SCM server logs the most, and you'll interact with these during our console troubleshooting chapter. Both logs record connection issues with the SEPM database. If you back up the database using the SEPM's built-in wizard, you can actually see entries in the backup.log file. There are several other logs that you can reference when troubleshooting issues with the SEPM. The primary Tomcat log that you'll reference is the SCM server log. It's the main SEPM log that contains almost all information-related activity to Tomcat web server. It also contains information related to the SEPM service status, as well as other subcomponents within the SEPM. Error.log is just that. It records errors related to Apache Tomcat. Access.log records client to SEPM communication and other requests. And for more information on how to debug SEPM in Apache, reference the KB articles on the screen. If you're troubleshooting a content distribution issue on the SEPM, there are 3 logs that you can reference. Log.liveUpdate records live update actions when live update runs. It records the files downloaded and if there were any issues during the download process. After live update finishes, you're going to see some activity in the scsm.lu.log file. During this phase, the SEPM records writing content to the database. After publishing content to the database, the SEPM writes content to disk. To see the events, you can reference the package publish task-0.log for more details. For more information on live update and content troubleshooting for the SEPM, see the KB on the screen. You'll also learn more about this process during the content distribution lesson. For client registration and other communication, the SEPM writes to 2 files, the ersecreg.log and the exccars.log. An excellent example of when you may have to look at these logs is if you suspect that cloned SEP clients with the same hardware ID might be trying to communicate with the manager. As a result, you might see that the client status frequently changes, different IP addresses or host names in the SEPM. You can use ersecreg and xccars to see the registration requests and any errors with communication. There is also a debug mode that you can enable in the registry. For information on these topics and more, see the KB articles listed on the screen. This diagram shows the logs most used when troubleshooting client communication and live update issues. ccservicehost.exe is the Common Client Service Host framework. It provides a multiple service hosting mechanism where as separate service plugins use ccservicehost.exe to run. For example, the SEP master service is a service plugin module and runs as an instance of ccservicehost.exe. As a result, you'll see multiple instances of ccservicehost.exe running in Windows Task Manager. Logging is another function handled by the Common Client Service Framework, so you'll work with it when troubleshooting client communication issues or scanning issues, or even general problems with the Semantic Management Client service. For live update, reference the log.lue file. I've included file paths for both sets of logs on the screen. For Scilink, it's customizable. You can actually specify the file path via the registry. You'll learn how to debug client communication issues in a later lesson video. When running the SEP client installation on a Windows-based computer, the installer runs the Microsoft installer first. Afterwards, setup runs the Symantec installer server. Both logs are written to the client's temp folder. If you need to review events or issues during an upgrade, both the RORU and rollback.log contain helpful information. For information on this topic and other helpful resources, see the article on the screen. You can reference the scilink.log for client communication or GUP-related issues. The debug log contains product start, content registration, component status, application lists, as well as network connection status. You can enable these logs through the Windows registry. You'll learn more about how to review these logs in the client communication chapter. I'll also cover how to enable debug logging for Linux and Mac clients. For Windows platforms, you can also enable debug logging directly in the UI. It's the preferred method for turning on client debug when the client is available. In addition to troubleshooting client communication, you can also gather logs for antivirus, definition failures, and scanning issues. You can enable vpdebug.log in the client UI or from the Windows registry. For more information, see the KB listed on the screen. For Windows platforms, you can also enable vpdebug logging directly in the UI. It's the preferred method for when the client is available. Although network threat protection debugging is written to the debug.log, to record the processing of firewall rules, you also enable TSC debug. For more information, see the KB article listed on the screen. You'll also learn how to enable TSC debug in the client communication and performance lessons. In this final topic, I'll show you how to use the semantic knowledge base and interact with support. The Endpoint Protection Technical Support page contains how-to and troubleshooting articles. In addition to searching for KB articles, the Best Practices link offers best practices for installing, upgrading, configuring, and managing semantic endpoint protection. From the Download Your Software link, you can download the most recent SEP version from File Connect. The Troubleshoot Using SymDiag link enables you to download SymDiag on Windows and Linux machines. It also provides a link to download the Gather Semantic Info tool for Mac clients. To open a support case, select My Symantec from the Support dropdown and sign into Symantec Identity. If you have a SIM account, or you have already created an account, use those credentials to log on. If you don't have an account, create an account here. Using this single sign-on application enables you to securely access all of your Symantec applications, including My Symantec, Symantec Education Services, PartnerNet, the Symantec Licensing Portal, Customer Care, and Symantec Connect. In this lesson video, you learned a systematic approach to troubleshooting and how to use Symantec and third-party troubleshooting tools. You also identified which logs to research when troubleshooting specific SEPM or SEP issues. In addition, you learned how to interact with Symantec technical support. For more information about the topics in this lesson, Refer to the resources listed on this and the following slides, and remember to frequently check the Semantic Support website. Thank you for watching this lesson video.